It's going to be a talk where I'm going to be talking about Flask, and I'm going to be talking about some of the key things that I learned recently while learning how to turn data science into consumer product. I know that's not the sort of thing that most data scientists get a chance to do, but I found it to be super rewarding, and I'm going to just talk a little bit about that journey and share some tips and tricks for how to work with that. So my number one goal for this session is to end on time, because it's 5 o'clock, it's after 5 o'clock now, and I'm sure you're all really tired. I know you love Python, but there's only so much you can hear about Python in one day. So I'll try to keep it tidy time-wise. But I'm going to introduce ShopRunner and our trending product service. And so that's a service that I recently built, and so a lot of these learnings are based on that. I'm going to introduce Flask, which is a really super cool framework in Python. And then I'm going to share some advice and very concrete examples for building a production level system using Flask. So first, to introduce ShopRunner, I don't know if any of you went to talks by Hannah and Nicole, who are my coworkers sitting here. They talked about PySpark and unit tests. But we call ourselves Amazon Prime for the other half of the internet. So we have 6 million members and a growing network of over 140 retailers. And our members get a bunch of great incentives to shop. They get free 2-day shipping, returns, and great deals. And our retailer partners win out too. The way we do that is by adding a layer of JavaScript to their websites that give them a bunch of cool new features. First of all, it links them with a bunch of new customers through our ShopRunner network. Those customers tend to be very engaged and give them increased conversion rates and average order values. And we have a growing set of technology features that go into that new layer of JavaScript, including, for example, Express Checkout. And we have a new mobile shopping app that's in beta right now and launching at the end of the month called District. So here's a sampling of some of the retailers in our network. So if you're interested in trying out ShopRunner for yourself, I have a bunch of free 1-year memberships up here. So please come up to me afterward and I can just give you one. So I'm going to be talking today about some very general lessons that you can take away, but the example for everything is this trending product service that we built, ShopRunner, that feeds currently 3 of our consumer products. So what we do is we take a bunch of data that we have on how our customers have interacted with all of our retailers, so across our network, and we figure out which products in our network are hot right now or trending. And we save that data in a database, and we have a Flask API on top of that then you can query that and get a quasi-infinite feed of what's trending right now. And you can filter it on a variety of different attributes so that you can personalize it to the customer. So one of the things that's in is our new mobile app, District. I have the District app icon and a screenshot of what it looks like. So the trending feed is the main landing page because a big part of that app is shopping discovery. Trending is also used in our members.shoprunner.com website. You can pick your favorite retailers and see what's trending for them. And then we also have a widget that shows you what's trending in different cities that we can put on our retailer partners' websites. And that's in A/B testing right now. So the stack for trending, there are a lot of pieces of technology that go into this, and I'm just going to briefly touch on them, but for the rest of the talk, I'm just going to focus on this portion of this diagram, the web app piece. But in brief, we have a bunch of data in a Snowflake data warehouse. We use PySpark on Databricks to manipulate that data and figure out what's trending. We then store the trending results in Amazon and AWS RDS in a MySQL database. Those are very optimized for being hit by an API, so it's much faster than using a data warehouse solution like Redshift or Snowflake. And then we have a web app built in Flask that uses SQL Alchemy to query the database, and GUnicorn is the web server in front of it. And then for all this, we're using Docker containers, we're using Terraform to build infrastructure. We use Jenkins for CI and CD, and the app itself is built in Amazon Elastic Container Service. So, who here is familiar with Flask? Okay, a lot of people, so that's good. So Flask is a really awesome framework for writing web apps in Python. And so I know this talk is at like an intermediate level, and I'm going to talk about some more like intermediate things, but just so we're all on the same page, if you have a model results, you're a data scientist, and you want people to be able to access those or whatever, but you don't want them to have to download and install something themselves. You want to serve up these results over the internet. Flask is a great framework for doing that. And there are tons of beginner tutorials on the internet aimed at just getting started with using Flask. So I'm not going to go over those things, but just know that there are tons of them out there. You can just Google data scientist Flask tutorial. So I'm going to talk about some of the more advanced things that you can do. And then there's GUnicorn. That is a product quality Python web server gateway interface. So it's just a web server that you have to put in front. So you define everything in Flask, and then you need a web server to actually create that connection to the user. Flask does have a built-in web server, and a lot of the beginner tutorials use that, but it doesn't scale well, and even in Flask's own docs, they say not to use it. So, which is true, like it just doesn't scale well. It's really good for prototyping, but then if you want to actually put something in production, I guess my first tip for you is to not use the built-in Flask web server and to use something like GUnicorn. So one issue that will come up if you're a data scientist and you have a model and it gives results, and you want to know if you should either pre-compute every possible thing that your API might return and store it in a database, or do you want to, say, have a machine learning model in a container and then run the user's data through that at request time? So there are different situations where one might be optimal over the other. But you want to ask yourself, is there a fixed universe of things that you could conceivably want to pass into your model? And if it's true that there is a well-contained fixed universe of possible parameters, then it could make sense to just put them all through the model, pre-compute it, store it in a database, because then the latency will not be as much of an issue. It's much easier to just query the database and get those results, or it's usually easier than to actually run a machine learning model at request time. So the latency can be a big issue there. So a few examples where you might want to pre-compute everything. So one example of that is the trending service that I've been talking about, because it's just like a feed of things, and it's really hard to say, give me like number 10,000 of the trending feed. Like there's no like model that takes in that number. It's just a list of things that I've pre-computed. You also could have, say, collaborative filtering recommendation systems where you're trying to figure out what products might be similar to other products based on who's purchased or viewed them in the past. And that's another situation where it's very timely and costly to compute that, so you want to just do it all at once overnight and just store it. But then there are a lot of examples where you don't want to do that, or you can't even do that. So examples would be where someone might give you data point that they want a result for that you've never seen before. So that could be a customer lifetime value model where a lot of the features are floats, or a computer vision model. Like there are some that we're building at ShopRunner where, for example, someone will give you an image and you give them back similar looking images. That's a sort of situation where like you can't just compute for every possible image you could receive. That's something where you have to compute it at runtime. And then if you are recomputing and putting things in a database, you have to choose between NoSQL database or a SQL database. NoSQL databases can be great if you can easily store everything as key value pairs. But if there's any kind of filtering that you're going to want to do, you really want to put things in a SQL database. So I'm going to walk through now for the next 15 minutes some examples of these tips and tricks for building a production system in Flask. And this is kind of like a sandbox scenario that I'm going to be using for all of my examples. And this is an extreme toy version of the trending service. So on the left side, I have a schematic of a SQL database where I'm storing results. So let's say once a night, I have a data job that runs in Databricks, and it computes what's trending for that day. And it appends this table with the new set of trending results, along with some sort of timestamp or date column. And then when we do that, there's also a run parameters table that lives in that same database where I am logging information about each run. So the most crucial piece of information that I'm going to talk about today is the date at which the run happened. So this results table is getting larger. I'm constantly appending to it. I probably want to have some way of cleaning it up too, so I'm not just keeping results forever. But as I append to it, I want to log like when the last append was in a really easy to use data table, like a very tiny params table. It's very easy to query. And that just gives me speed. And then on the right side, I'm writing out some of the code that I will have for this. There's a filtered request module, and that does a few things for me. I'm going to define a filtered request class, and I'm going to show you in a couple slides. I have some functions that will compose SQL queries for me, depending on like what query parameters people give me, and then a function to format the results before I send them back to the user. And then that gets imported by the main app module, and that's app.py. So in there, I have the app config with Flask. I figure out all the logging. I configure that. There's a bunch of nice error handling you can do in Flask that I'm going to talk about. And then I have functions that define all the different endpoints that I'm going to have. So for example, one endpoint I'm going to have is, let's say you want the 10th most trending item today. You give me the number 10, and I return to you information about that item. So my first piece of advice that I have is that if you're going to be using SQL, a SQL database to store your results, because maybe you want to be able to do a bunch of filtering, like with the trending service, SQL Alchemy, or Flask SQL Alchemy is really awesome. So if you have like a web app and a web server and you have database connections, it can be kind of overwhelming to know like how exactly to maintain those database connections, like what happens when you lose your connection, like how do you start a new one. That's kind of stuff can get kind of overwhelming to the data scientist, but if you use Flask SQL Alchemy, it actually handles all of that stuff for you. So I'm just showing you here like an extremely simple way that you would start your app. So this could be like the top of my app.py file where I just compose a database URI based on a bunch of credentials that I have in a configuration file. And then I set what's called the SQL Alchemy database URI part of this app config. So app.config is just something that Flask has to just store all the configurations of your application. And this is just a predefined thing that it uses for Flask SQL Alchemy. So you just feed that the database URI, and then you can define or instantiate this DB object, which then you'll use for all of your queries going forward in your app. Another tip is to use one logging handler. So if you have a web app, it could have many different pieces of it that have different loggers involved, different loggers that they use. And it's really helpful to take all those logs and put them all in the same place. And you can do that by taking advantage of what are called handlers that the logging objects have. So here, what I'm doing is I'm combining the logs from both the Flask app itself, which has its own logging, and then gUnicorn, which is my web server, which also has its own logging. And so you can find the logger for gUnicorn and then set the app handler to be equal to that handler, and then all those logs will go to the same place. And then you can also you should also have different environments for your application. So you're building consumer product, you have the concept of the production app, but you don't want to push new changes directly to that. So you'll have the concept of a whip environment or a staging environment for trying things out before they actually get pushed out to customers. And so you can have different logging levels for different environments. So for whip, you might want a logging level of debug because you want to see every single thing that can go wrong. But then for production, you probably want to reduce that logging level because you don't want to just be overwhelmed with too much logging. Another thing that was non-obvious to us when building this application is what happens when we're updating the data. So one thing that you definitely don't want to do is you have a table of data results that your app is pulling from, and you want to update it, so you drop that table and you build a new table. That's not a good thing to do because when that table doesn't exist, your API is not going to have any data to access, and then everything will fail. So you need some way of updating your data and then logging information about the data update in a way that the app can use. So again, I'm using the app config for this. So again, app.config is, you can store anything in there you want. And so what I'm doing in this getDate function here is storing the date of the most recent data update. So if you remember from my toy example before, this data set gets updated every day by appending a data table, but things can go wrong there. There could be that something breaks in the data job and the data didn't actually get updated that day, so you can't always assume that the date that you query for in your API is going to be today or whatever the most, yesterday if it runs at night. So this is a good way to log that information so that your app has access to it. So what this code here does is it stores two things. It stores something called current date, which is the current date that's the date you want to query for in your SQL. And then there's something called last update. So it's telling you the last time you checked that information. And it's making use of this params table that I mentioned before that stores all the parameters about every run of this data job. So I just go to this tiny little easy to query table that I have. I query it for whatever the current data is, and then I just store that information. So then in my API, when I'm defining my endpoints, I just access this config, or I can run this getDate function. I get this date every time, so then I can put that in my queries. Another thing that really helped us a lot, we first didn't do this, but then eventually ended up doing it because there are just so many different query parameters that ended up coming into our Jira backlog. And so it became way easier to maintain the code by creating this filtered request class. So this trending feed, if you want to personalize it for customers, you might want to filter it by what department you want to shop in, like men's, women's, children. You might want to filter it by like what city you live in or what zip code you're in, maybe min and max price or something's on sale. There's just this exploding list of query parameters that someone might want to give us when they access the API. So this class does a lot of things for us to keep our code tidy. So when you instantiate one of these things, a filtered request object, you give it several things. You give it the DB object, so you tell it what database to use. Here you'll see there's an offset and a limit. Those are for pagination. So in SQL, if you do a SQL query, you could get a tremendous number of things back. And so let's say I just want items 0 through 20 or 1 through 20. Then I make the offset equal to 0 and the limit equal to 20. But now let's say I want the next 20. I want the second page. Now limit is still 20, but now offset is also 20. And then you can just keep incrementing the offset by whatever page size you want. So those are two things that the user gives us. And then also, in Flask, you can have query parameters that are either just one thing at a time. So I'm saying, you need to give me just one city. You can't have multiple cities, just one city at a time. But you can also have some parameters that are lists. So maybe you might want a whole list of retailers. Let's say there's a product that uses trending where a customer gives them a list of their favorite retailers. And so they want to filter down this list to that list of favorite retailers. And so you look at the request arguments, and you can just get one, or you can get a list. And then in this class, there'll be a bunch of methods to query the database. So you'll format a bunch of SQL based on these queries, and then format the response that you'll give back. And so then how using this would look in the actual Flask app.py module, where you're actually defining your endpoints. Let's say you have a results endpoint here. So what you do is you look at request.args, or just like the request thing. That's telling you all the query parameters that the user has given you. And then you can parse that out in Flask and then create this request object that's one of these filtered requests. So if you see here, there's request args, there's the current date. I'm using that get date function to figure out what date I want in my SQL queries. I'm getting the offset and the limit from the user, and then building this request. And then let's say the filtered request class has a get results function. So like I'm just using that to get what I'm going to return to the user. One big gotcha here with doing filtered requests in Flask is that there are URI limits, and they depend on what browser you're using, but 2,000 characters is a pretty safe bet. So you want to keep the URI below 2,000 characters, but then let's say someone wants to give you a giant list of query parameters. Well, then that might not be less than 2,000 characters, and it won't work. So what you can do is, instead of a get request, which is what most of this will be, someone's getting data from me, you can do what's called a post type of request. So what this code here does is it allows for both gets and posts, depending on how the user wants to use the API. And then it checks to see, with request.method, it checks to see if it's a post or a get. So if it's a post, I'm saying, OK, this is going to be a JSON request, and I need to parse the JSON. If it's not a post, then I'm assuming it's a get. It's not a JSON request, and I can just get request.args in the standard way. These are all very standard Flask objects that are at your disposal to do this. There's like really not much boilerplate that I had to do before this. Another thing that can be tricky to the data scientist who's not, a back-end engineer is what exactly HTTP status codes mean, and like exactly how to return an informative error message. It's very easy within Flask to define different error handlers. So you see the decorator app.error handler. What I'm defining here is an error handler for a 400 request. And as a data scientist, that's going to be probably the status code, aside from a 200, that you'll use the most, is when people try to use your API incorrectly. So what you can do is just define a bad request function like this that takes in the error, and it looks at the error description, and it just returns that to the user in the response. So what this will do is, like, let's say someone tries to request more than 100 items, and I've decided that that's not OK. If limit is greater than 100, I'm going to use the Flask abort function with a 400. When it sees the 400, it looks for this error handler, and it returns what this error handler prescribes. So it'll return a 400 code, and then this message that I encoded in here cannot request more than 100 items. So you can look at all the different edge cases, things you don't want your user to do, and define a function like this. Also, like a couple other error codes that are kind of confusing. 404 not found. I actually was in the middle of an argument with two back-end engineers arguing over what this means. But basically, if you have an endpoint that does not, like someone tries to hit an endpoint that doesn't exist. So let's say we have a retailer's endpoint and someone tries to go to retailers/ABCD and that doesn't exist. That would be a legit use of 404 because that endpoint doesn't exist. But then let's say we have a queryable endpoint, this results endpoint, and someone puts in ABCD as a retailer. that should actually give you a 200, which is like the good request, like you did it right message, and an empty list because the user used the API correctly, it worked, it queried, it just didn't find anything. So that actually is a legit thing and not a 404 not found. Whereas a 206 partial content is also something a data scientist probably is never going to use. That's only to indicate when only a part of the response has been returned, and it's only to use when your API intends to return data in chunks when throttled. And then one last thing that I want to talk about is the issue of latency. So this isn't something when building this API I first really thought very deeply about. Of course, I knew we didn't want it to take a really long time to run, but I didn't really think like of all the consequences that would happen if it wasn't actually super fast. So latency, when you're pre-computing results, is not just about slowness, but also about your database load. So if you write your SQL queries in very inefficient ways, not only will your app be slow, but your database CPU might get overwhelmed. And then if you're using SQL, definitely don't want to use joins. That will just make it very slow. It's better to just store more data and actually pre-join everything you would want to and store it that way than actually do a join in your API. Build good indexes on any data sources. That is for NoSQL and SQL. So the data is stored in the most efficient manner for the API to access it. And then also, you could add a cache. So this is something that we recently tried with the trending API. There's query caching that comes with some databases where it just logs in a key value store, like what queries it's tried and what the results are, so it doesn't have to bother the database. You can add something very similar yourself with a key value store like, say, Redis. And then there are lots of settings to whatever web server you're using that you can play around with to help with latency. And so, for example, for gUnicorn, they have really good docs on all the different things you can try. So you can change the number of workers or threads. There are different worker types like synchronous and asynchronous that might work for different use cases. And then there's also like timeout that you need to tune for your particular use case. So just to recap everything that I've gone over, I want to say Flask is great. There were a lot of like Flask standard things that come with the package that I was using here. So the app config, app.request, like there are lots of things already built into Flask that make it very easy to write to write up these endpoints with not having to do a ton of boilerplate yourself. If you're doing pre-computed results and storing them in a SQL database, I also highly recommend Flask SQL Alchemy because you'll handle also the boilerplate of dealing with a SQL database. I would suggest using one logging handler, or at least thinking very carefully about where exactly your logs are going to make sure that in all your different your development environment and your production environment that you're really seeing everything that's going on. You need to prevent downtime whenever you're updating your data. So I encourage you to make use of the app.config that you can use in Flask to store information about what data set you can use and in creating redundant data sets. You can keep your query handling code from getting out of control by putting it into a class. That makes it much easier to maintain. If you have long lists of query parameters, there are query length limitations you could bump up against. So in that case, use a post instead of a get. And then the Flask error handlers are very powerful, and they're great for building informative custom error messages for all the different HTTP status codes you could come across. And I encourage you to actually research what the different HTTP status codes mean, because the idea is that this API you're building for your data science is going to be consumed by back-end developers. And if those HTTP status codes don't make sense to what they think they should mean, then that'll make them sad and not want to use your service. And you want them to like using your service. Just a few last cool things. You should look up Postman. So that's an API development environment, but it's really good for like storing test queries and test cases and sharing them to your coworkers. Swagger is a very popular way to build documentation for APIs. And there's this repo called Flasker that you can use it's like a combination of Swagger for Flask. So it's really easy to get started with building Swagger docs in Flask. And then we use Datadog at ShopRunner for all of our metrics and monitoring. It's been really useful. You can just add decorators to functions that will log things for you, and then you can just build custom dashboards so that you can monitor things like latency and different error codes that have come up, and you can even set alarms. It does like simple anomaly detection on all these things that you're monitoring, so that's super useful. So that's it. Thank you very much. Again, come up to me at the end of the talk if you want a free 1-year membership to ShopRunner. And does anybody have any questions? Thank you.
Yeah. So
there are microphones here.
So how do you package like models that it seemed like you had like a really interesting like set of things for handling like SQL queries and things like that.
Yeah.
The things that actually like do the predictions and stuff like that, like where do you usually put that? How do you usually handle that?
Yeah, so if you want to have a model that actually, I think that me might have follow-ups, but so for the example that I talked about today, everything's, all the data science, all the pre-computation was done, like we did it in Databricks. And then from Databricks, it's stored in a SQL database. And then the API doesn't really do anything but query that. But then let's say you have a model and you want to run the user's request through your model. When they're doing that, you can have your model just like have the artifact of your model, like pickle it and have that artifact in a container. And then build that when you build your service, and then it's totally possible to have that into to use the user's results at runtime. But then there are also services that do stuff like that for you as well. So I know AWS, they have like Amazon SageMaker is something that we've been using for our computer vision code because it like does a lot of that stuff for you. And then if you had computer vision models, you also use TensorFlow serving. Like there are lots of different frameworks that are built to help you do that. But it's basically you can just have the model artifact and then just run it in a Docker container. And then when people give you parameters they want to put into it, just run the model in the endpoint definition. So. Or you can have a separate module that does those things and then feeds it, and then that gets imported into app.py if you want to keep them separate. Yes?
I recently looked at Flasker and a bunch of different alternatives, and found some of the alternatives were a little nicer to use. Did you
Okay.
have to try any of the others inside Flasker?
Yeah, so this is like, that was a new thing to me, and I just kind of put it out there as like an extra because I can't speak authoritatively on it. Like, what other alternatives did you like better?
One is Flask Rebar.
Flask Rebar?
Yeah.
Okay. And that's like a documentation, like an automatic documentation service that, does it build Swagger docs?
All of them do that.
Okay.
Flasker has like a million different ways to use. This one, it's just much simpler.
Okay, cool. So if anyone didn't hear that, like Flasker is not the only option out there to build Swagger docs with the Flask API. There are other options out there that might be simpler and better suited to your needs that I'm not aware of, including Flask Rebar. Yes, okay. Any other questions? I know it's really late. All right, thank you.